All right, we'll keep working with antiderivatives, differential equations, and now we'll just look at some applications. So to review, and also just to look at a little different notation, we could have the initial condition written like this, and if we have function notation, let's change to Leibniz notation. Separate the variables and integrate. That's the general solution, and then we find the particular solution by solving for c. So the y value is -1, x is 0, the x value is 0, and we have c equals -1. So the particular solution is here we have to have two initial conditions because we have the second derivative, and so we have to do the antiderivative here, solve for c, and then do the antiderivative again and solve for c. So if we want to solve the differential equation, we can start with just saying second derivative should be d squared y dx squared, but we can just say we're moving up one level to the first derivative. So if we write it like this, another way to say this would be if y equals f prime. If we let y equal f prime, then this is the correct notation. Do the antiderivative. Solve for c, and the y value is 6. The x value is 0. So we have the particular solution. And we would say that f prime of x is 1/3 x cubed plus 6. So now we need to find the solution to this, and we can just say y equals f of x. So dy dx is 1/3 x cubed plus 6. So we'll just start over with a new Leibniz notation, separate the variables. Integrate. And substitute for the y. We have y is 3, x is 0. Y is 3, x is 0. So we put a 12 there, and we have c equals 3. So y equals 1/12 x to the 4th plus 6x plus 3. And we would write f of x equals 1/12 x to the 4th. So there's the particular solution. So here we're given velocity, and we need to find the position at t equals 3 if x equals 7 at t equals 0. And then also, they'll explain that the object is moving horizontally, and so that's why we would have an x. If the object was moving vertically, they might use a y here. And we have two ways of doing this. Find the position at t equals 3. We can solve it with a differential equation. This just says find the position, but if it said find the position function, we would have to use a differential equation. If it just says find the position, we have a shortcut. Also, let's look at this with the levels of rates, and we would say that x is the position function, x prime is the velocity, that's also v, and then x double prime is acceleration. So we're just considering the different notations. We're starting with velocity, and we're moving up to position. So we know we need an antiderivative. All right, so if we have velocity, we're at the derivative of x. So if we say dx dt is equal to 3t plus 1. This notation is just more familiar when we have to separate variables. And we have x equals 7 when t equals 0. X equals 7 when t equals 0. So we have c equals 7. And the position function is x equals 3/2 t squared plus t plus 7. If, and then it says find the position at t equals 3. So now we have x of 3 equals that's 27 over 2 plus 10. We have 23 and a half. All right, if it just asks for position, we can also do this. Start with the initial position plus the integral from 0 to 3. 0 to 3. We have an initial time of 0, and we're going to a time of 3, so that's how this is set up. And then we just do this. And this uses the fundamental theorem, which we've already covered, but at this point in the book we haven't covered that yet. All right, substitute the 3 in both. Subtract, substituting the 0, 0 plus 0, and we end up with the same value because we have 7 plus 3 is 10, and then there's the 27 over 2. So we get 23 and a half. Okay, so similar problem. Make sure you look at the levels of rates. Consider the different notation and which way we're moving in those levels. Pause the video and try that one. Acceleration is given. Find velocity. And if the object is moving horizontally, we would say that this would be x of t. We could also, we don't need it for this problem, but we can talk about that notation also. We're starting on acceleration and moving to velocity, so we know we need the antiderivative. Let's look at, let's go ahead and use, we'll say that y equals velocity, just so that we can use Leibniz notation, or we could just say dv dt. Don't do that. Let's say that we want to find velocity. We have the derivative of velocity here. dv dt is, so that notation can vary. Right now it's just allowing us to separate variables. And the integral can be on the outside of the -4, or the -4 can be on the outside. That doesn't matter. All right, and we'll solve for c. We know velocity is 10 when t equals 0. So c is 10, and we have velocity equals -4/3 t cubed plus 10. Let's find the velocity at t equals 4. Velocity at 4 and we get -75 1/3. All right, so this is more like an IB or an AP test question. And find the velocity and the acceleration. We're starting with position, and we can just say it's moving horizontally to visualize it. And let's think about this. If we have x is here, x prime would give us velocity. X double prime is acceleration. So if we're starting on position and moving down, we use the derivative. Move down again, we find the derivative again. So we need to have the derivative of x, and that's going to be 2t minus 3. So that is vt. V of t is 2t minus 3. The second derivative would be the derivative of this, and that's the acceleration is 2. Find the times when the object moves left. So moving left, we look at velocity, and we need the sign of velocity. If the object is moving horizontally, then left will be a negative velocity. All right, so direction is determined by velocity. We already know velocity. We want to know when this is negative. So we want velocity less than 0, 2t minus 3 less than 0, t is less than 3 over 2. So moving left on 0 to 3/2. Find x when v is 0. When velocity is 0. So we need to find out when velocity is 0. Well, we already did that. If this was an equation, we would put an equation here. We know t at t equals 3/2, velocity is 0. If we just reworked that, we would say that velocity, when is velocity 0? 2t minus 3 equals 0. And we end up with t equals 3/2. We know velocity is 0 at t equals 3/2. So find x when the velocity is 0. And we just substitute into the position function. So the position function was t squared minus 3t, and we'll go t squared minus 3t. 9 over 4 minus 9 over 2, and we get negative 9 over 4. All right, and then average velocity. Average velocity. If we have position, velocity, and acceleration, when we see the word average, sometimes we use the integral and sometimes we use the slope formula. So here's how we determine which one to use. We need the average velocity, but we're starting on position. So if it says find the average and we're moving down a level, that means we need the slope formula. So the average velocity is going to be, velocity average is, we could think of it like this. The slope formula, and then in this case it's going to be x of 10 minus x of 0 over 10 minus 0. So now we're going to substitute a 10 into the position function, and that's going to be 10 squared minus 3 times 10. And then we'll have 0 squared minus 3 times 0 over 10 minus 0. And we get 70 over 10. So the average velocity is 7. All right, a particle is initially at rest. There's the initial condition without giving any numbers. an initial condition. It moves along the x-axis such that the acceleration for positive time is this. Here's an initial condition for position. All right, pause the video. Try to do as many of these as you can. And here we go. Find the velocity and position functions. Well, let's consider where we're starting. We're given acceleration. Find velocity and position. We need to move up. So that's the antiderivative. Initially at rest, that means that t equals 0, velocity is 0. So we could say t equals 0, velocity equals 0, and then we also have t equals 0, x equals 3. So those are two initial conditions that we're going to need for this one. Let's go from acceleration to velocity. So we have the derivative of velocity is cosine t. That's acceleration is cosine. That allows us to separate the variables. Okay, we need to solve for c. We know that velocity is 0 when time is 0. So c equals 0. And we have velocity is sine t plus c. So there's the velocity function. And we know that velocity is the derivative of position. Oops, 0. All right, and that allows us to separate the variables, integrate, and we have negative cosine t plus c is the general solution. We know that x equals 3 when t equals 0. X equals 3 when t equals 0. Then we can solve for c. X equals 3 when t equals 0. So that's 1. Cosine of 0 is 1. We have a negative 1. We're going to add it, and we get c equals 4. So the position function is negative cosine t plus 4. Okay, find t when the particle is at rest. Find the time when it's at rest. At rest means velocity is 0, so we'll just take the velocity function that we just found, which is sine t, and find out when that equals 0. Sine t equals 0. Sine is y over r. We want to know when the y value is 0. So we know at t equals 0, pi, 2 pi, the velocity will be 0. Find when the particle is moving to the right. Moving right we need to know the sign of velocity. We want velocity to be positive. So let's think about the graph of sine. We know that between 0 and pi, velocity is positive. Here's the graph of velocity. If velocity is positive, it's moving to the right. So moving right. Go ahead and look around. Moving right between 0 and pi, and then between 2 pi and 3 pi, and then we'll go to part D, find the distance traveled at t equals 3. Okay. Distance traveled. We could find the distance traveled is the integral of velocity from 0 to 3. So we have the integral of sine we get negative cosine 3 minus negative cosine 0, and this is approximately 2 if we do that on the calculator. All right, and the difference between, if it says distance traveled, we would use this. If it said position at t equals 3, we would use this. So this gives us a different answer if we wanted to know the position, because the position is the distance traveled plus the initial position. Let me just check that. We have negative cosine 3 plus 1. The distance traveled is 2, and that would mean that here's the distance traveled. It's not working out just right. But anyway, that's the distance traveled. Okay, we'll stop there.